Now, a particle of mass m kg lies on top of a smooth sphere of radius, here you are, and it's m kilograms, and it's lying on top of there. The sphere is fixed on a horizontal table P. The particle is slightly displaced, so you're talking a minimum force, just ever so slightly to the right, and it now slides down the sphere. The particle leaves the sphere at B and strikes the table at Q. Find the speed of the particle at B, and then find the speed it hits the table at Q. So in a nutshell, you're going across, and you're staying in contact with your sphere. But then at this stage now, you leave it, the R value becomes 0 at this point here, and then you leave your table, and now you're undergoing gravitational acceleration. Now, when you leave the table, you have two velocities, don't you? You have sort of one going to the right and one going down. Which one stays the same, and which one gets accelerated after you leave the table? Down gets accelerated, but going to the right remains the same. So what I'm trying to say there is that this one gets bigger while the other one stays the same. And then at the end of the question, you're going to use Pythagoras' theorem to figure out what is your new vertical velocity, compare it to the original horizontal to find your new speed that you hit the ground at. So you know what you have to do, just a matter of doing it, okay? So here's what happens. We're going to get rid of that for a minute, and we're going to bring that back up. Now, it's motion in a vertical circle. How do we know it's a vertical circle? Well, look at it. It's on its end, facing you. If it was a horizontal circle, guys, you'd be looking at something more like this, lying along the table in a flat surface. So what we're basically been able to do there is distinguish between the two techniques. That'll be a horizontal circle, and then the other one is most definitely a vertical circle. So you have to go to your vertical circle equations. So your two vertical ones are the centripetal acceleration. Now, we have two choices, don't we, for centripetal acceleration? We have centripetal force, even. Force slash acceleration, they're both pretty much the same thing. We'll start off with force, okay? Centripetal force, F, can be mv squared over r. What's the other version? Anybody remember? mr omega squared. Now, which one to use and why? It wants speed. Doesn't say circular velocity, angular velocity, does it? It doesn't say angular speed. So that rules out part 2. So we're very much in the mv squared over r camp there. Now, what I'm going to do is I'm going to draw a diagram regards this. I'll actually just make a bigger one. Okay, and P is here. Okay, so that's P there, and that is Q's over here. Don't really have to worry about Q at the moment, and I'm looking at point B. So what I'm going to do is go to the center of the circle, and I'm going to make a diagram here. So that's going up and across. Everybody happy enough with that? Now, I'm going to call this angle alpha, so that'll give me the displacement angle. I'm going to call R is always, R acts which way, guys? Which way does R act? Always perpendicular to the tangent at that point. So the tangent at this point would be along the center, basically. If that's a tangent there, the R value is always acting directly out from that. For this type of question, because it's supporting it from underneath. Okay. What way does the weight of the particle act? And that's mg, because the question told me it was m, right? Now what I'm going to have to do is I'm going to have to work on the what's it called? The have to have to make the forces parallel and perpendicular to the radius to work the first equation. So to work the mv squared over r equation, I need forces parallel and perpendicular to radius. So that's always the case for this type of question, okay? So I'm going to do, the only one that's not qualifying at the moment is the mg, isn't it? The mg is the one that's causing the hassle because the r is in that direction but the mg isn't. So what I'm going to do is I'm just going to make a bigger line out of that again. So here's my mg. I'm going to draw a line like this and then like this. So that's my mg formula now. So we're going to start working on that. Okay, anybody get me any angles here? 90 minus alpha, everybody agreed with that? Makes this one alpha, makes this one 90 minus alpha, makes this one here alpha. Okay, and I'm just going to rub out all that, what I did there. I'm basically using two sets of alternate angles as the quick way of doing it. Now I'm here. Okay, that's mg. Now alpha is here, so that makes this one mg cos alpha, makes this one mg sine alpha. Which one's acting towards the center of the circle? Mg sine is going directly up on the tangent, so it's mg cos alpha. Okay, so force has two components. It has mg cos alpha, that's coming diagonally left down. It has r, which is acting directly up, and then it has mv squared. What's the radius of the circle? It's 2 meters. That's my first equation of motion, okay? Now, what do we know about the point B? What happens to the r value at the point B? R equals 0, because it's just about to leave the vertical circle. So this means that mv squared equals mg cos alpha. Now we've exacted everything we can out of this diagram, so this diagram can more or less disappear for a minute. Well, yeah, just try and get rid of the extra parts. Now, and this part here. Now, back to the second one. Does anybody remember the second formula? Conservation of energy. I have it slightly done differently here, but we'll work with it. K1 plus potential energy 1 equals KE 2 plus PE 2. What's kinetic energy, you guys? Formula for kinetic energy? I have mv squared for potential energy. Anybody remember? Mass times gravity times height. Now, what is your kinetic energy at the start of the question? Are you moving? No. What's your kinetic energy at the end of the question as you leave with its velocity v? So what's your kinetic energy at the end of the question? A half mv squared, because you're exiting the point B at velocity v. Now, your potential energy at 1, what is that? Okay, we're taking this here as the baseline. We're taking the bottom of the circle as the baseline. So how high are you above that baseline at the start of the question when you're here? You're 2 meters and another 2 meters, which is going to get me 4 meters. Is that alright? So that's 4 mg. Now here's the hard one. How far are you above it at the end? So Remember what we said earlier? You're 2 meters to here, that's great. Now you're going to have to find out the difference between this one here and this one here. You need to find that blue height to make this work. So, I specified that as alpha earlier on, didn't I? Then I can specify that as alpha. I can specify that as 2, being the radius. So, I need to find out this part here, don't I? So what function am I going to use? Sine, cos, or tan? Oh, sorry, this one here. Sine, cos, or tan? Cos. So cos alpha equals, we'll call this h, equals h over 2. H therefore equals 2 cos alpha. Now my total height is going to be now, guys, from here to here, all the way down. It's going to be 2 plus 2 cos alpha. Add both of them together. So mg times 2 plus 2 cos alpha. So let's move this guy over this side here. And we're going to get half mv squared equals 4mg. I'm going to multiply that out and drag it over at the same time. Minus 2mg minus 2mg cos alpha. Then I'm going to get 2mg minus 2mg cos alpha equals a half mv squared. I should bring down my other one here. And then what I'm thinking is I'm going to multiply both sides by 2. What happens when I multiply both sides by 2? Just gets rid of that. Turn that into a 4 and that into a 4. And then I can now replace mv squared with mg cos alpha. That's a lot of mg's, isn't it? So 1, 2, 3. 4 equals, bring over the 4 to the other side. It'll equal 5 cos alpha. So cos alpha equals, I got 2 over 3. What is with that? Which one? This one here? This one. What did I miss out on? It is 2mg cos alpha. Yeah, mv squared equals 2mg cos alpha when I cross multiply up to 2. So that's where it's a 2mg. Okay. So what happens then? The 4 goes over to your side, is it? So what I get here is what do we get here, guys? It's that's 2mg cos alpha, right? So that is, I'll just write it out long. Taking shortcuts is getting in my way. 4 minus 4 cos alpha equals 2 cos alpha. Ah, it's fixed now. Perfect. 4 equals 6 cos alpha. Cos alpha equals 2 over 3. Yeah, that's the correct answer. That's actually what I got here. Now, what we're doing next then, guys, is we have to find out V. So what we have a formula over here, don't we? mv squared equals 2mg cos alpha. The m's will cancel. And then we're going to get V equals the square root of 2g cos alpha. We know that cos alpha is 2 over 3. So V therefore will equal the square root of 4g over 3. Is that right, guys? 4g over 3. Now, what does it hit the ground with is what we're trying to figure out. Okay, so what we can do next is we can move the, yeah, we're going to use the conservation of energy again. So what I'm going to say here is that I'm going to go back to the very top here. Actually, I'll redraw the diagram. We're currently at this one here, and that's it's leaving that velocity v. Okay, and it's going to pick up velocity because of gravity, and then when it hits the ground, it's going to be going at a faster final velocity. We call it v1 than it starts off with. Now, how high off the ground was it at the beginning? Two plus two cos alpha from earlier on. Yeah. We know the value of alpha though, don't we? Yeah, value of alpha is 2 over 3. So we can actually use that value straight away. So it's going to be 2 plus 2 times 2 over 3. So what's that? 4 over 3 plus 6 over 3 gives me 10 over 3. So you're 10 over 3 at the start above the ground. Okay, so we do what we did last time. KE1 plus PE1 equals KE2 plus PE2. So what we're going to get is your kinetic energy at the start is a half mv squared, but we know the v value, don't we? What's the v value? V is the square root of 4g over 3. Therefore, v squared is 4g over 3. Our potential energy, we found it there a second ago. 10 over 3 is the height, so it's mgh. So the height is 10 over 3. So it's going to be 10 over 3 mg. What's our kinetic energy at the end? We don't know. It's the whole point of the question. A half mv1 squared. And then its potential energy at the very end, when it hits the ground, 0. So what I'm going to have on this side is I'm going to get rid of all those m's. Don't like them. A half v1 squared. Now that is going to be 2 over 3g plus 10 over 3g, which will give me 4g, because it's 12 over 3g, equals a half v1 squared. Multiplied by 2, we get 8g, equals v1 squared. V therefore is the square root of 8g when it hits the ground. There we go. Okay.